Well, hello again. Couple more sections to cover here in chapter 11, and then we'll be reviewing and taking a test the end of this week before your Easter break. Or no, this is after Easter break now. Doing these in advance. Anyway, so let's get to it. So I guess that would mean your test would be on Friday then. What we're doing today is we're going to find areas of regular polygons. And to do that, we're going to have to be doing a little bit of a sine, cosine, tangent today. So hopefully you remember how to spell SOHCAHTOA. See if I can remember how to spell it. So sine is opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent. So here, if we need to solve for x, we pick our angle, which is 34 here. X is opposite, and 8 is the hypotenuse. So opposite and hypotenuse is going to be sine. So remember, it's sine of our angle, which is 34, and then opposite over adjacent. So x over hypotenuse, sorry, x over 8. So then we multiply both sides by 8. So when we do 8 times sine 34, comes out to be about 4.47 here. If we go to the nearest hundredth. Next one, so we have 60. Again, from 60 we have opposite and hypotenuse. So this one also is going to be sine. So this would be sine 60 equals the opposite 12 over hypotenuse. So remember, when you have one like this, you're not going to be multiplying, because if you make it a proportion, and you did cross product, so you would get 12 equals x times sine of 60. So to get rid of the sine 60, we got to divide both sides by sine of 60. So 12 divided by sine 60 is 13.86. So we'll be doing that a little bit today. So we're doing areas of regular polygons. Remember, a regular polygon has all equal sides and equal angles. So that's where we're finding the area of today. Could be hexagon, pentagon, octagon, all those. As long as they're regular, we'll be able to find their areas. So some vocab you need to know. So when you have a regular polygon, you have a few things. First of all, it seems kind of silly because, well, they're not circles, but you do have radii. So a radius, when you talk about a polygon, goes from the center to each vertice. So this red one's a radius, this red one's a radius here. So center to a vertice where the two sides meet up. Next we have an apothem. So an apothem is the distance from the center to each side. So remember, when we find the distance from a point to a segment, that's always going to be a perpendicular segment here. So it's always going to make a right angle, this apothem. So as you see, we'll have some right triangles here. That's where our sine, cosine, tangent stuff will come in. And then we also have this central angle here, which is also going to be important. So a central angle is formed by two consecutive radii. So this angle here is called a central angle. All right, so find the following. It's a regular hexagon, so that's what we know. We want to find the measure of angle ACD. So that would be this angle right here. Now, if you think about it, we kind of made, a triangle here, triangle here, triangle here, triangle here, triangle here, and then this whole triangle here. So what we should have is 6, since it's a regular polygon, 6 equal angles. Well, a circle is 360. So if we take that 360 divided by 6, we get our central angle, which is 60 degrees. So to find that central angle, we take the number of, we take 360 divided by the number of sides, okay? Because that'll be how many angles we have in the middle. Next is ACB. So ACB here, want to find this angle, use a different color. So that angle is actually just going to be half of 60. So we just take 60 divided by 2, and we get 30 degrees. And we know we can divide it by half because these two triangles would be congruent by hypotenuse leg. So that's why these two angles are the same. And then finally CAB. So if we want to find CAB, so this angle, well, we know triangles add up to 180. So 180 minus the 90 here, minus the 30 here, would give us 60 degrees. And that's that. All right, so to find the area, okay, we do have, excuse me, I can't talk today. So in a regular polygon, you have all these radii, and you have congruent triangles. Okay, so all 5 of these would be congruent because the radiuses are all the same, and all these sides out here are the same as well. So side, 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 or side angle, side, either way you look at it, these triangles are congruent. So if you think about it, if we wanted to find a side of one of these triangles, we would have to do 1/2 its base times its height. Okay? So if we're just thinking about the one triangle, our height is really actually going to be, see if I can draw it right, since it makes a 90-degree angle, it's actually going to be our apothem. So we can think of 1/2 the apothem times each base. Okay? Well, each base, well, we have 5 triangles. So we have 5 bases. And if we add up all the bases, what we'd have is the perimeter. So it actually, for the whole polygon, ends up being 1/2 the apothem times your perimeter. So that's our theorem for today. So copy this down in your composition books so you can use it later. So again, area of a regular polygon, 1/2 the apothem times its perimeter. So let's try a few. So here we got a regular octagon. Here's our formula, 1/2 AP. So our area is going to equal 1/2. The apothem here is 5. And then our perimeter, well, each side is 3.5. So 3.5 times the 8 sides. So 3.5 times 8 is 28. So the perimeter is 28. And then we multiply all that out, and we're going to get 70 inches squared because we're in area. We also need to find angle ACG. So ACG, that's our central angle. So if you remember to find that angle, we take 360 and we have 8 sides. So 360 divided by 8, and that's going to be 45 degrees. And there's that. All right, area of this regular dodecagon. So now we got 12 sides. So again, area is 1/2 AP. So here we're going to have 1/2. Our apothem we know is 6. But the problem is we don't know our perimeter. But we can find our perimeter. We have a right triangle here. So that means we can do a little Pythagorean theorem. So that would be 6 squared plus, we'll call it x squared, equals 7 squared. So x squared is going to be square root of 13, if I'm doing my math right, which I think I am. So we have square root of 13 for this little guy right here. So to get the whole perimeter, well, we have 12 sides to the dodecagon. This is only half a side. So it's really, we're going to have to take this times 2, and then times 12. Well, if it's times 2 times 12, it's going to be times 24 to get our perimeter. So, and actually, we could just plug all this in at one time. So we'll say 24 and square root of 13. So this part here is our perimeter. So we multiply all that out. And we get about 2 59. That's an ugly 9. 0.6. And no units here, so we'll just leave it at that. So that's that one. All right, time to do another one. So regular pentagon. So again, we're going to do 1/2 AP, but we don't know either the A or the P. So what we're going to have to do is we're going to have to draw in, and if you draw in your textbook, please draw lightly with pencil. You're going to have to draw in the apothem here. Okay, well, we got to find our apothem. So in order to do that, we're going to need to find some angle measures. So the one way that I like to do it is find this angle right here. Now remember that our central angle, which would be this whole guy, is 360 divided by the number of sides. So 360 divided by the number of sides, which is 5, is 72 degrees. So that means that just half of it, so this one here, would be 36 degrees. So we have this angle here, and we have this side. We want to find the apothem. So we have the hypotenuse and adjacent side, so that's cosine. So we're going to have to do cosine 36 equals adjacent, so let's call it A. So A over 4. So we do 4 times cosine 36. And we get our apothem at about 3.24. So let's put that here. I'll write it down here too, so people aren't confused. All right. And then the last thing we need is the perimeter. So now we need to find this guy here. So a couple things we could do. We could do sine 36 equals x over 4, or we could do Pythagorean theorem. Either way, I'm going to do sine. So sine 36 equals, I'll call this guy x over 4. So now I take 4 times sine 36 and get 2.35. And that's half a side. So we got to times it by 2 to get the whole thing, and then times 5. So times 2 times 5, so really times 10. So that's going to give us a perimeter of 23.51. So we multiply all that together. And we get about 38.09 in inches squared. Okay, on to the next one. Oh, that was the last one. Perfect, because I only have about a minute and a half left. Make sure as you're doing this, you are using degrees on your calculators, not radians. If you don't have a calculator, you can use the internet. You can download an app on your phone. I'll also be sending you guys in an email a link to a graphing calculator that you can download to your computer and use that. So check your email. I probably already sent it to you a while back. Here's your assignment. Yeah, so just keep up on the assignments. I will let you know when and how to turn them in. Don't worry about it until I tell you or send you an email about it. Hope you guys are doing well and enjoyed your weekend.